Got another fun project I'm working on here. This is a water pump out of a, I believe it's 1929 Greavette. It's a Kermath engine. And anyway, it quit pumping. And it's pretty common. These gear type water pumps are very reliable. There are no rubber parts that deteriorate and disintegrate. Rubber impeller pumps are easy to service and work on, but when the impellers do fail, they usually wind up with little rubber bits all through the water system, and it's very difficult to deal with. The gear pump, the biggest problem with the gear pump is sometimes the gear, if it gets sand in here, it will end wear the end plate. And I'm just going to take this apart and show. I've actually taken it apart before. I thought I'd make a video of it. The biggest common problem here is you can see here this plate, the top gear has basically worn a notch here. So when there's excessive end clearance on top of the gear, the water just slides by and the gears aren't really having any effect. So normally I would just take this plate and lap it on a piece of emery paper on like a table saw or a flat surface to get rid of this groove. However, this groove is excessive. It's about a little over a 1/16 of an inch, maybe closer to an 1/8. And there's no way I'm going to flatten that plate that much. I'm going to run into other problems if I do that. So I've got a TIG welder, and I've never tried this before, but what I'm going to do is I've got some bronze filler rod, and I actually tried it yesterday. Taken my TIG torch and heated it up, and I'm going to have to fill this with bronze brazing material, and then I'll have to mill it off and then eventually lap it flat, and then that will take up the end gap in the gears and the pump will work again. But then I got thinking, like, why did that happen? I've never seen one where it grooves so much. And I'm going to grab the other end here. This is the body of the pump that goes into the crankshaft, or the crankcase. And it's basically driven by another gear inside of the engine. I actually took the pin out of this, had to grind the ends off and press it out. This is what turns it, and I was looking at the seal at the end here, and it looks like there was some kind of a spacer, because I noticed there was a lot of end float in this gear that let the gear kind of rub against the end of the plate. So it would be foolish to just do the end plate and put it back like this. So then I got looking at the drive cog of the gear. It's hard to get a picture of this here, but it's deteriorated too. So I think what's happening is whatever the tang is that's driving this is basically ramping up and putting a lot of end thrust on this. So I'm going to have to maybe get my MIG welder and weld a bunch of material on here and remachine it out before I put it together. The other thing I think I'm going to do is I'm going to put a little washer here. There's a seal here that keeps the oil from coming out of the engine because it's open here. It would just be dripping oil if I didn't have a seal. So the seal is there, but I think there was probably a cover here that was supposed to take the end thrust of this drive cog to keep it from pushing this gear. So it's going to be a little more than a 5-minute job. That's why I just thought I'd make a video of this. You know, a lot of people with stuff these days, they just say, well, we can't get parts and we'll put a Mercruiser in it. But these old engines, it's it's almost 100 years old, and it's been running quite well. It's actually a beautiful running engine, dual ignition and everything else. But this water pump, you just can't order one on Amazon. So I'm kind of committed to getting this one going. I don't profess to be a great welder, but I think I've got enough material on there. It's a bit of a blob. Looks like a bit of a mess right now. But what I'm going to do next is I'm going to let this cool down. I'm not going to quench it in water. I don't want to shock the metal. I'm just going to let it cool, and then I'm going to put it in the milling machine and take a lot of this blob off and face it flat, and then I'll lap it on some emery paper to get it flat. as close as I'm going to go with the milling machine. I just don't want to go any deeper on the parent metal. Let's make sure it's not too hot. And I'm going to take it and lap it on some coarse emery paper now. The other problem I have is I'm not sure whether this is sitting parallel on the milling machine, so I just don't want to mess it up. I'm going to flatten this out with a file, take a bunch of the meat off. There's a possibility that all the heat I put into this plate may have warped it a bit, so it's going to be within the range where I can file it flat, and then I'll finish it off with some emery paper on the top of the table saw or the bandsaw on a nice flat surface. You notice I've got some blobs around the hole. I'll just take those out with a die grinder. Just on some, I think it's about 200 grit emery paper. Just trying to get a nice flat surface. I think the heat I put into this might have cupped it up a little bit, but I'm getting pretty close. I've just got a few low spots here. I think that'll be another probably another 45 minutes of rubbing like this, and it'll be nice and flat. Just going to turn my attention to this drive dog now. I'm just looking at this wear in here. It looks like this is probably the source of the problem. Where does maybe when they put the gear on, unfortunately I don't have the engine here. It's a long way away. I thought it was something I could just do in the boathouse. When I initially started, I thought I would just bring the pump back here, take the end plate off, and lap it, and that would be it. But I think this is the true source of the problem. And I don't know whether whoever put the engine together might have put a pin here instead of a tang, but it looks like something has created a notch here, and it's ramping up and putting a lot of forward thrust on that gear, which is going to be a problem. I could put it back together the way it is, but I'm sure this would just recreate the problem in a couple of years or even sooner the way it is. And I'm thinking the boat was overheating. I'm thinking maybe this thing just became totally disengaged. So this I'm not going to TIG weld. I'm going to MIG weld this, and then I guess I'll put it in the lathe and machine it, and then I'll have to do that notch again in the milling machine and then pin it back onto the shaft. I have marked the shaft, and I've got a bit of grind here where I had to take the pin out, which I didn't have to grind on the other side. So this way I can make sure it's on the right way, because sometimes holes aren't exactly 180 degrees to the axis of the shaft. There's the drive dog after a clean up in my blast cabinet. The thing with welding is you got to make sure stuff is really clean. Oil just turned into smoke and keeps things from sticking. But looking at this more closely now, I can see where that is a pretty bad wear. Now for the little drive dog. I'm switching from the TIG welder to the MIG welder. MIG is a little easier to use. I'm still not good at either one of them, but I think I can do an adequate job here. While the other part is cooling, I'm going to make a spacer here that's going to ride against the seal, and that will keep the drive dog from putting thrust on the gear and wearing out the pump. So I've got the body of the pump here, and this is the washer. I've got the inside diameter machined out. Now I have to make the outside diameter. So what I'm going to do is I have a thing in my chuck in my lathe. It's an expanding mandrel, but it's a little bit too big. The next size is too small, so I'm going to machine this expanding mandrel down so I can put this washer on and hold it, and then I can turn the outside diameter. Okay, I've just taken a little cut off of my expanding mandrel. I can still use the back of it, but this one will fit that washer. And the way these work is it's got a little expanding screw in here. I'm going to turn the screw in, and that's going to expand the the segments of this expanding mandrel and hold this washer tight, and then I can machine the bore or the outside diameter so it's a nice fit on the internal diameter of the pump body. Okay, I've got that little washer machined. It's certainly a lot easier than finding a seal to replace that. I think the steel part is in pretty good shape. So this is bottoming on a shoulder, and the seal is also bottom on a shoulder, so that's going to keep the drive dog from thrusting the gear and remachining the thing. So now it's on to doing the drive dog. Now to just finish off a couple of gaskets, and then I think I can put this together. Well, there it is, all ready to go back into the boat. I guess tomorrow I'll take it back up. It's been a lot of work to get this done, but just by comparison, I was looking on the bench here. I have a water pump out of a 350 Mercruiser, and this is the easy way to do it. You just go and buy another one. It's about $1,100 for one of these things now. And this is an older one. The newer ones are just plastic, and they're not really repairable. I think this one, it could be serviced. The problem with this one was the seals are gone on it. I just haven't gotten around to rebuilding it, and haven't had a need to do that yet. But this pump should be good for another 100 years, I think, now.